Alright, so we're going to take a look at an example here of calculating the density of an unknown substance, comparing it to the density of some known substances, identifying the known or the unknown substances, calculating some of our error or tolerance, and overall coming up with a density with its tolerance for this unknown substance that we've now identified. So we're going to start by looking at our volume and mass of an unknown substance. And to calculate the density is just equal to mass over volume. But if I were to graph the volume versus a mass here, this would be my independent variable, and thus would go on the x-axis. And this would be my dependent variable, which would go on the y-axis. Which means I have volume here and mass here. Which means my slope is just going to be mass over volume. Now I know something about my slope formula. And my slope formula, if I remember it correctly, is m is equal to y2 minus y1 over x2 minus x1. Now when we did our lab earlier this year, we calculated density by doing a linear regression on our data points in Desmos. You could do that, or I could just pick two data points. And what I'm going to do is I can pick any of these data points. I typically like to use the smallest x and y values, which would be sample 3 here, and the largest, which would be sample 4. So I'm going to call this point 2 and this point 1, which means I can then substitute my values in here. These would be my y values. These would be my x values. So therefore, this is x1 and y1 and x2 and y2. So I can just substitute those into my equation at this point. y2 is 1.1. I'm going to subtract 0.0114 from it. And then for my x2, 2.75. 2.75 again, minus 0.03. And that's going to give us a value of 0.40 kilograms per liter, which is also going to be the same as 0.40 milligrams, or sorry, 4.04 grams per milliliter. And you could do that conversion if you wanted to. So that would be our answer. Now, let's take a look at some of our known substances. Well, looking at our list, we can see it's going to be none of these because it's going to be wood. And so we can identify our unknown substance as wood, which again has an expected value of 0.40 grams per milliliter, or it could be kilograms per liter. Now we need to calculate the tolerance. Now the tolerance is the amount above or below the calculated values as are they compared to the actual density of the object. So what we want to know is we've calculated densities at 4 different positions here, or we could have calculated the density for our 4 samples. And we're going to look at how our samples differ above or below, greater or less than our actual value for wood. So we're going to calculate all 4 densities. As you'll see, I've written down each of the density calculations, and I'm going to do that now. So 0.21 divided by 0.50 is going to be 0.42. We had 2 significant figures here, 2 significant figures here, so our answer should have 2 significant figures, which it does. 0.75 divided by 1.82 gives us 0.412 and a bunch of other numbers, but this has 2 significant figures, this has 3, so we go to 2 significant figures, which gives us 0.41, 0.0114, that, by the way, has 3 sig figs, divided by 0.03, which has 2 significant figures, so our answer, our quotient should have 2 significant figures, is 0.38. And then finally, our final answer, our final quotient, again, would have two significant figures. 1.1 divided by 2.75 is 0.4. Now, looking at these values, this first value is plus 0.02 above the calculated value. This is 0.01. This is actually 0.02 below. And this one is even. There's no change there. So if I wanted to calculate my tolerance, I see I'm going to look at my highest value above, which is 0.02, my lowest value below, which is 0.02, the greatest value below, which is 0.02, and I can actually say I'm going to be plus or minus 0.02 of my calculation, compared to my calculations versus the actual. Of course, the density of my unknown then, what I would say from my calculations, would be 0.40 plus or minus 0.02 grams per milliliter. And I use milliliters because in this experiment, this was an uneven or ununiform, or non-uniform, I should say, shape. That means it was odd. It wasn't like in a square or a rectangle. It was something harder to calculate. Okay? All right, so that would be my answer there. So if I were to ask you to calculate the density from these substances, or from these values here on this table, I would get 0.40 plus or minus 0.02 grams per milliliter. The 0.02 here reflects how my calculations for each individual density were above and below. The 0.40 is basically from my slope formula. Again, to remember, my slope formula here accurately represents the density of a substance. That is the mass over volume if I go back to my graph. I could have selected any of the 2 points here and come up with a density at or around 0.40 grams per milliliter or kilograms per liter. If you do the conversion like I said earlier, they're going to be the same. Now that you've finished that, you have two objectives. One, I want you to work on the density quiz that's going to be available for you. So please work on that. That comes next in the module. After that, I do strongly urge that you go look at the example I wrote for the conclusion from the lab discovering density that we did earlier this year. That's going to help you as to give you an example of all the elements that are important in a successful conclusion. Good luck. I'll see you in class tomorrow as we do part 2 of the performance assessment.